Dear students, now let us go into the ionization of water. Water is a very weak electrolyte. Ionization of water. Water is a very weak electrolyte. It ionizes only slightly. It ionizes only slightly to give H plus ion and hydroxide ion. Very, very weak electrolyte. Ionization is to a very small extent. But we said water exists usually, hydrogen ion usually exists as hydronium ion, but by combining with water. H plus H2O plus. H plus get combined with water to become H3O plus. That's what we have seen. Since it is available in the combined state, I can write H2O, one more H2O, that is 2 H2O. One H2O will become H3O plus. Alright? Nothing wrong in writing the equation like this. Both are correct only. If I write in terms of only H plus, I can write like this. H plus and OH mean this is correct only. This is also correct because hydrogen ion exists in the form of hydronium ion. I have added one more water molecule. If we try to write equilibrium constant K is equal to molar concentration of hydronium ion into molar concentration of OH minus ion divided by molar concentration of water square. If we consider this equation, it will be K is equal to hydrogen concentration to hydroxide ion concentration divided by concentration of water. But water will be present in very large excess. The number of hydrogen ions and hydroxide ions which get ionized is negligibly small, and therefore concentration of water will remain constant. Since it is a constant, it can be coupled with this constant to get ionic product of water. Kw is equal to hydronium ion concentration to hydroxide ion concentration. Kw is equal to hydrogen ion concentration and hydroxide ion concentration. Even if we write as H plus or OH minus, it makes no difference. Because after all, water is a solvent. It is going to be a constant throughout the course of the reaction. Its concentration may not going to change. So, this is called as ionic product of water. Ionic product of water. Kw is referred as ionic product of water. Earlier we have seen Ka, ionization constant of weak acid, Kb, ionization constant of weak base, and Kw, ionic product of water. Now, at about 25 degrees Celsius, the value of ionic product of water is found to be at 25 degrees Celsius 1 into 10 power minus 14 mole square decimeter to the power minus 6. Because it will have equal concentration of hydronium ion and hydroxide ion, maybe 10 power minus 7 mole per liter of hydrogen ion and 10 power minus 7 mole per liter of hydronium ion might have formed, because equal number should be formed. If 1 mole of water get ionized, 1 mole hydrogen ion, 1 mole hydrogen ion, hydroxide ion. Here, at 25 degrees Celsius, 10 power minus 7 mole only get ionized. At 25 degrees Celsius means 298 Kelvin. 273 plus 25 will give 298 Kelvin. Maybe this temperature. At this time, the temperature may be 25 degrees Celsius. So, at this temperature, 10 power minus 7 mole per liter of hydrogen ion and 10 power minus 7 mole per liter of hydroxide ion may be available. So, if we multiply 10 power minus 7 into 10 power minus 7, 10 power minus 14, mole into mole, mole square, liter per liter into per liter, liter to the power minus 2, liter is nothing but decimeter cube, therefore, per liter square means per decimeter to the power minus 6. So, this is the value of ionic product of water. Alright. You should understand. Ionic product of water is 1 in 10 power minus 14 mole square decimeter to the power minus. Any aqueous solution, in any aqueous solution, we will be having this much of the product will be this much. Any aqueous solution, maybe acid, base, or neutral solution. If it happens to be aqueous solution, the concentration of hydrogen ion and hydroxide ion in acid solution, basic solution or neutral solution, the value is found to be this much. How? Earlier we were talking about ionization of water. Now I am saying acid, base or neutral, anything will have. The reason is hydrochloric acid, if it get ionized, it will give hydronium ion concentration and the chloride ion. Alright. Now we have got only hydronium ions. Then how can I say the product of the concentration of hydronium ions and hydroxide ions will be equal to this much? Even in the solution, what I am saying is Kw for this solution is this much. That's what I said. For an aqueous solution of acid, base or neutral solution or even water, not only for water, any aqueous solution will have Kw only this much. How? Here, from hydrochloric acid, we get some concentration of hydronium ion. But since it happens to be aqueous solution, this ionization might have existed. This ionization might have established earlier. It is because of that hydroxide ions will be available. Hydroxide ions will also be available. Now, we have to add the hydronium ions from these two. Since hydronium ion concentration become excess because of the availability, hydroxide ion concentration will become, since it become excess, it get reduced. How? Reverse reaction might have been happened as per Le principle. In an equilibrium situation, if we increase the concentration of any one of the component, the equilibrium will be shifted in the opposite direction. That is Le principle. And therefore, if I add hydrochloric acid into water, what would have happened? More hydronium ion might have been formed. Since more hydronium ions are formed, hydroxide ion will try to come back. So, little hydroxide ion concentration might have been reduced. But the product will be constant. Product of hydroxide ion and hydronium ion will be constant. So that's why I'll be, when we go deeper, you will be understand very well. In acid solution or basic solution or in neutral solution, the product will always be a constant. How? Suppose if I take, say, an acid solution containing 10 power minus 3 mole per liter of hydronium ions. Acid, say hydrochloric acid. It has got this much of hydronium ion. Naturally, hydroxide ion concentration will be very less. How much? 10 power minus 11 mole per liter. At which temperature? 25 degrees Celsius. At 25 degrees Celsius, this is the case. If I multiply 10 power minus 11, if I multiply the two, 10 power minus 14. 10 power minus 3 into 10 power minus 14. Base is the same, minus 3 and minus 11, sum will become 10 power minus 14. So this is how we get. When, if it is an acid, concentration of hydrogen ion will be excess. Hydroxide ion will be less. If it is a base, concentration of hydroxide ion will be greater and hydronium ion will be less. So in the case of neutral solution or in the case of a neutral solution, now I can tell you, in the case of a neutral solution or water, hydronium ion concentration is equal to hydroxide ion concentration is equal to 1 in 10 power minus 7 mole per decimeter cube at 25 degrees Celsius. Remember, at 25 degrees Celsius. For acid solution, if it is an acid, hydronium ion concentration will be greater than hydroxide ion concentration. But the product will be equal to 1 in 10 power minus 14. So hydronium ion concentration will be greater than 10 power minus 7, maybe minus 5, minus 4, minus 3, like that. Hydroxide ion concentration will be lower, maybe 10 power minus 8, minus 9, minus 10, minus 11, like that. In the case of base, hydroxide ion concentration will be greater than hydronium ion concentration. But the product is always this value. Product is same. So neutral solution, acid solution or basic solution, this is the value at 25 degrees Celsius. But for acid, hydronium ion concentration will be higher, and for base, hydroxide ion concentration will be higher. For neutral solution, it will be equal. All right. So now you might have understood the concentration of product of the molar concentration of hydronium ion and hydroxide ion is equal to 10 power minus 14 at 25 degrees. Again and again, I am saying minus 25 degrees Celsius. Why? Ionization is endothermic process. It proceeds with absorption of heat energy, endothermic. Therefore, if we give heat energy, what will happen? More and more of water may get ionized. And therefore, concentration of hydrogen ion and hydroxide ion will be higher. Maybe at 40 degrees Celsius, it may be 10 power minus 13. Higher means 10 power minus 13 product. Kw may be greater than 10 power minus 14, maybe of the order of 10 power minus 13 minus 12 like that. If we reduce the temperature to say 10 degrees Celsius, the ionization will get reduced. When the ionization gets reduced, ionic product will get reduced. Therefore, it may become 10 power minus 16 like that. So, now you might have understood the concept of ionization of water. Water will give equal concentration of hydronium ions and hydroxide ions. Therefore, the product is this much, which includes 10 power minus 7 mole per liter of hydronium ion, 10 power minus 7 mole per liter of hydroxide ion at 25 degrees Celsius. If temperature is higher, the value will be higher. Higher in the sense 10 power minus 13, minus 12 like that. Minus value will get reduced, should get reduced. If the temperature is reduced, ionization should get reduced. The value will become less, 10 power minus 15, minus 16, etc. In the case of acid and base also, product of hydronium ions and hydroxide ions, that is ionic product, will be a constant. Here, what hydrogen ion from Cl as well as hydrogen ion from water is also taken into consideration. Sometimes you may wonder, 10 power minus 7 molar HCl. Is it neutral solution or acidic? Can you guess and tell me? Hydrochloric acid get completely ionized. If it get completely ionized, what is the concentration of hydronium ion? 10 power minus 7 mole per liter of hydronium ion. If it get ionized completely, this is the value. It is the value for a neutral solution. Only for a neutral solution, this value is applicable. But we are given as an acid. How is it possible? It is because from hydrochloric acid, we have got very less concentration of hydrogen ion, and the concentration of hydrogen ion available from water should also be taken into consideration. If we consider that also, it will be slightly increases. 1 in 10 power minus 7, 1 in 10 power minus 7, therefore 1 in 10 power minus 7 plus 1 into 10 power minus 7 will become 2 in 10 power minus 7. So, slightly it will get increased. It is because of slight increase, the pH value will slightly become less than 7. pH will be discussing afterwards, but for acidic solution, the concentration of hydrogen ion should be greater than this much. That is happening. How it is happening? Hydrogen ion available from water should also be taken into account if it is a very dilute solution. When the hydrochloric acid solution or sodium hydroxide solution concentration is very less, of the order of 10 power minus 6 and less, we have to add the concentration of hydronium ion available from water. What does it mean? So now, basic ideas you might have understood. What is it? Ionic product is a constant value. For water and neutral solution, this is the value. For acid, this will be greater, this is lower. Product is always 10 power minus 14. For base, this is greater, this is lower. Product is same at 25 degrees Celsius. If temperature is lowered, the value will be lowered. That means 10 power minus 15, 16, etc. When temperature is increased, the value is increased. That is 10 power minus 13, minus 12, etc. Now, I am going in for yet another point. That's what I touched here. You may get confused. That's why I am going to repeat once again. What is it? If it is a very weak acid, hydrochloric acid, acid should have hydrogen ion concentration greater than 10 power minus 7. But if hydrochloric acid concentration itself happens to be 1 in 10 power minus 7, we have to add the concentration of hydronium ion available from water. Water ionizes to give equal concentration of hydronium ions and hydroxide ions. Hydrochloric acid upon ionization produced hydronium ion. Alright? Since it happens to be 10 power minus 7 molar, very, very weak means it can be 10 power minus 7 molar. If it is the case, concentration of hydronium ion will be 10 power minus 7 from HCl. We have to add hydronium ion from water also, 1 into 10 power minus 7. That means it is 2 into 10 power minus 7 mole per decimeter cube, which is slightly higher, and therefore it becomes acidic. We need not add the concentration of hydronium ion available from water if it is a strong acid. If it happens to be a strong acid, say 1 molar. 1 molar solution means, what is the concentration of hydronium ion? 1 molar. Here we need not add the concentration of hydronium ion available from water, because it is very, very strong. Or 10 power 1, let me say, 10 power 1 or 10 power minus 1, very high. 10 power minus 1 itself is high only. With the 10 power minus 1, I need not add the concentration of hydronium ion available from water, 1 in 10 power minus 7. If I add, what will happen? What is this value? It is 0.1. What is this value? 0.000000001. 1, 2, 3, 4, 5, 6, 1. If I add, what will happen? 0.10000001. It will become, what is this value? So addition will become meaningless if the acid happens to be strong. If the acid happens to be strong, the addition of hydrogen ion from water need not be taken into account. But if it is weak, say 10 power minus 6 and less than 10 power minus 6, this addition become meaningful. If I have a crore rupee and 1 more rupee if I have or not, it is meaningless. I have 1 crore and 1 rupee, I need not say. But suppose if I have only 2 rupees and 1 more addition of 1 rupees happened, that becomes meaningful. So now I should say I have 3 rupees. When I have a crore, I have a 1 crore and 1 rupee, I need not say. That's how when hydrochloric acid happens to be a very strong acid greater than 10 power minus 6, we need not add the concentration of hydronium ion from water. Likewise, when the base sodium hydroxide, say, if it is a very strong base of concentration 10 power minus 6 and more, 5, 4, 3 like that, we need not. But 10 power minus 6 and above and less means we have to add the concentration of hydroxide ion available for sodium hydroxide. If it is this order, concentration of hydronium ion from water should also be taken into account. When I deal with this few problems, you will be understanding. Now you may have little bit confusion. What for he is saying like that? The thing is, in any aqueous solution, hydronium ions and hydroxide ions are available. The product is 10 power minus 14 mole square decimeter to the power minus 6. This value is known as ionic product of water. That product is constant for any acid or any base. Suppose if it is a very weak acid or very weak base, the contribution of hydronium ion from water should also be added. If already it is strong, this contribution is meager, we won't add. That's what I am saying now. And when we go into one example and one evaluate yourself, so that you will be understanding this idea very much. What is it? Kw is, what is the Kw value? Can you tell me? 1 into 10 power minus 14 mole square decimeter to the power minus 6 at 298 Kelvin, 25 degrees Celsius. Now, an example. A fruit juice contains 2 into 10 power minus 3 molar hydronium ion. That is the example sum. A fruit juice contains this much of hydronium ions. You are asked to find out the hydroxide ion concentration. You are asked to find out the nature of the solution. What is the given data? A fruit juice, hydrogen concentration this much. You are asked to calculate hydroxide ion concentration. You are also expected to say the nature of the solution, that is fruit juice. First point, since the concentration of hydrogen ion is greater than 10 power minus 7, it is acidic, that is nature. When the concentration of hydronium ion is greater than 10 power minus 8, it is greater. 10 power minus 3 is greater than 10 power minus 7. Therefore, it is acidic. So, for nature, I can say it is acidic. Why? Hydrogen concentration is greater than 10 power minus 7. It is this much. Now, what is hydroxide ion concentration? We know that hydronium ion concentration to hydroxide ion concentration for any aqueous solution is 1 in 10 power minus 14 mole per decimeter cube. Mole square decimeter to the power minus 6. Now, hydronium ion concentration is given. So, hydroxide ion concentration is equal to 1 in 10 power minus 14 mole square decimeter to the power minus 6 divided by, what is the concentration of hydronium ion? 2 into 10 power minus 3 mole per decimeter cube. Molar means mole per liter, mole per decimeter cube. If I divide, I will be getting answer. Mole, square get cancelled. Minus 6 become minus 3. Mole per decimeter cube. Unit we have got mole per decimeter cube. Now, what is the answer then? 1 by 2 means 0.5. 10 power minus 3, when it goes over to the numerator 10 power 3, 10 power minus 11. It will become 5 into 10 power. I have multiplied it by 10. I should divide, therefore minus 12 mole per decimeter cube. That's all. Am I correct? So, the hydroxide ion concentration of the solution is 5 into 10 power minus 12 mole per decimeter cube. Since hydrogen ion concentration is greater than hydroxide ion concentration, it is acidic. Or since hydrogen ion concentration is greater than 1 power 10 power minus 7, it is acidic. In both ways, I can say. So, that is about example sum. And one more question under evaluate yourself. What is it? You are given with Kw of a neutral solution as 1 into 10 power minus 14 mole square decimeter to the power minus 6. Kw this much, 4 into 10 power minus 14, not 1 into. Is it possible? Is it possible to have Kw value greater than this? Yes, it is possible. When the temperature is increased, Kw value may increase. It is a constant at a particular temperature. When temperature is increased, ionization will get increased because it is endothermic. So, it may be slightly higher than 298. Therefore, Kw value is this much. And they asked you to find out hydrogen ion concentration and hydroxide ion concentration. Being neutral solution, hydronium ion concentration is equal to hydroxide ion concentration. And the product is equal to this much. Kw is nothing but hydronium ion concentration into hydroxide ion concentration, which is equal to this much. So, if it is equal, what does it mean? I can say hydronium ion concentration square is equal to 4 into 10 power minus 14. Am I correct? Yes, it is equal. I can replace hydroxide ion concentration by hydronium ion concentration. I can replace hydronium ion concentration by hydroxide ion. Both are same. It's equal to this much. Therefore, hydroxide ion concentration, hydronium ion concentration is equal to. I have to divide. I have to take root. 4 into 10 power minus 14. Root of this much. If I take root, it is mole, it is decimeter to the power minus 3, which is equal to 2 into 10 power minus 7, slightly higher. Hydroxide ion concentration is equal to hydronium ion concentration is equal to this much. If hydronium ion is this much, definitely hydroxide ion is also this much. Being a neutral solution, usually 1 in 10 power minus 14. When temperature is increased, it may become higher. Therefore, now hydroxide ion concentration become equal to hydronium ion concentration, which is equal to 10 power minus 7. Thank you.